in this video we are going to discuss about how to convert the Xs-3 code into the BCD conversion. So before you start, all of you should know what is Xs-3 code and what is binary coded decimal. So in the previous video I have already told what is the Xs-3 code, what is BCD, how BCD can be converted into Xs-3 code. It means that if there is a BCD code, then if you add plus 3 with that, then it become Xs-3 and it is written as Xs-3. Now, so this is the BCD to Xs-3 conversion, means BCD plus 3 is equal to Xs-3. Now, if we convert Xs-3 into BCD, it means if Xs-3, that is 3 subtracted from the Xs-3, then we can find the BCD code. Okay, so for your convenience and to make the shorter video, we have already write down the decimal number 0 to 15 and the Xs-3 code. So why we have written 0 to 15 instead of 0 to 9? Because you see that in Xs-3, if you want to convert the Xs-3 code into the BCD code, we have to convert Xs-3 code to BCD code, means we have to subtract 3 from the Xs-3 code. So if Xs-3 code is considering 0, then 0 minus 3 is equal to minus 3. So that cannot be represented in the BCD code. Like 1 minus 3 is equal to minus 2, 2 minus 3 is equal to minus 1. These three cannot be written, cannot be converted into the BCD code. So we are taking the cross from the 0, 1 and 2. So from 3, so Xs-3 is, if the Xs-3 code is 3, that is, this is the Xs-3 code, this is the BCD code. So if the Xs-3 code is 3, then the BCD code becomes Xs, that is 3 minus 3 is equal to 0. So here the BCD code is 0. Like that, so we can change the color to make it more attractive. So this becomes 0. So it means that the in Xs-3 the 3 is the starting number that we can convert into the BCD code, and the last number is 12, because in BCD we know that binary number, the decimal number, is from 0 to 9. If 3 is the starting number, so 3 plus 9 is equal to 12. Up to 12 we can convert. It means that, so if it is 0, then this become 1, this become 2, means 4 minus 3 1, 5 minus 3 2, 6 minus 3 3, like this. So we can write the codes of the corresponding number, and the way of writing is same. So we can easily up to 7, that means we can easily write 0 to 9, 0 to 9 by 3-bit number. But if we want to convert, means if we want to represent the number from 0 to 15, we should take the 4-bit number. So it becomes, so we can write it as, so we can easily convert this, and this 8 should return 0, and last two are 1. It means if we convert this BCD into the Xs-3 code in the BCD, so we should convert from 3 to 12. So here is the input is the Xs-3 code. That's why we are taking in the Carnot map. We should find B3, B2, B1 and B0. So the output is your B3, B2, B1 and B0, and the input should be E1, E2, E3 and E0. So we can make the Carnot map for that E3 as taking E3, E2, E1, E0 as your input, and corresponding output is B3, B2, B1, B0. It means first of all we have to, if we are going to find the B3, so for B3 the 1 we getting in the position 11 and 12. So in the position 11, and the position 12, 11 and the position 12 we are taking 1, and the to make, so we cannot make the Carnot map with this, so we can take some don't care condition. If we are taking the don't care condition like this, then we can easily make two group. One is like this, here is your first group, and corresponding second group is this. So it means that red is the group 1, and so B3 become group 1 plus group 2. What is group 1? So group 1 is nothing but, so E3 and E2 are constant over here, so it become E3, not E3 E2, we have to write it E2 E3, E2 E3, and so it is E2 E3, and everywhere it is changes, so we cannot take the vertical column. For group 2 it becomes, here it is, so for this horizontal column it is E3 is 1 and 1 and E2 is 1 and 0, that means E3 is same, so we have to write E3, and that is here it is the both are E1 and E0, both are 1, so it is E1 E0. This is the output of the B3. That means we are getting the B3 as E2 E3 plus E3 E1 E0. Like that, if we are taking the Carnot map for the B2, then what is the position of the 1? At 7, at 8, at 9 and at 10 we are getting B2. So 7, 8, 9 and 10. So that means here 7 we can change the color again. So 7, 8, 9 and 10 we are getting the numbers. So now to make the Carnot map convenient, we can take two don't care over here to make a 4 group, and obviously here if we are taking one another don't care, then these 4 corner we are getting another group. So and also if we are taking one don't care over here, then we are getting the 4 group. So first group we can consider the red color, that is the first group, not like this, that the group is should be like this is the first group. The second group becomes taken as white color, this one, this one, this one and this one. This is your second group, and third group is your here. So what is the B2? B2 become group 1 plus group 2 plus group 3. So what is the output of group 1? If we are taking the group 1 is that 4 white corner, then here E1 0, here E1 1, here E0 0, E0 0, so means E0 is not changes, so E0 bar is there. And if we are looking over here, E3 0 1, E2 0 and 0, so E3 is changes by E2 is same, so E1 E not bar and E2 bar is here in your group 1. Okay, now if we consider this as group 2, then these two red color group 2, then so we are considering here that is the 0 0 0 1, means E1 bar is there, E1 is not changes, E1 bar is there, and here so 0 0 1 0, that means 0 0 1 0, that means E3 is changes but E2 is same, so E2 bar is there, E1 bar and E2 bar. Plus in group 3 we are changing the color. In group 3 obviously E1 and E0 are same, so E1 E0 take as it is, because they are 1, so we cannot take bar. And here E3 is 0 1 and E2 is 1 1, that means E2 is also 1, so E1 E0 and E2 is the output. So now we can simplify this thing. So we can take E2 from first group, E2 bar, taking the color change, it is become E naught bar plus E1 bar. So and it is not E1, we can take, so from here if we are taking, so all here both are bar. These two have the both have bar and these two have both have bar. So if we are taking E2 bar common, then these become E naught bar and plus E1 bar plus take E2 E1 E0 as it is, then again, so E naught bar and ER bar we can write it as E naught E1 whole bar plus E2 and taking E2 outside E1 E naught E1. Now it become easier, so we can take E2 XOR XNOR, it is not XOR, it is XNOR E1 E naught. This is your expression for B2. Now go to the next, that is the for calculation of B1. So to calculate the B1 we should know what is the position of 1. It means 5, 6, 9 and 10. These 4 position we are taking the B1, that is the 5 6 5 6 9 and 10. So 5 6 9 and 10 we are taking 1, so 5 and 6, then 9 and 10 we are taking the 1. So we should take don't care. If we take 4 don't care over here, then we can make 4 group. One is this group, one is this group, and another is this group. So if we want to calculate the B1, so B1 become group 1 plus group 2. So taking this as white color as group 1, so what is the, so E1 and E0 are not changes, so E1 is 0, so it become E1 bar, it become E1 bar, and E0 is 1, so it becomes E0. And here E3 E2 all are changes, so we cannot write anything like that. For group 2 here obviously E1 and E2 is not changes, and all other the horizontal columns are changes. So if we consider E1 and E0, so E1 is 1, so E1 and E0 is 0, that means E0 bar. So taking, so we can write E1 bar E0 plus E1 E0 bar, we can take it as E1 XOR E0, E1 XOR E0. Okay, so considering the fourth case, that is the B naught. So B naught, how can we calculate B naught? So for B naught the position is 4, 6, 8, 10 and 12. 4, 6, 8, 10 and 12. So write down 4, 6, 6, 8, 10 and 12. Now we can easily take one don't care over here and one two don't care over here, then we can get only one group, and it is a big group of 8 1. So take this and this as a group, so b1 become group 1. So what is the value of this? So it becomes here e1 is 0 1 0 0, that means e naught bar is there, and all the e3 and e2 are changes, so b naught is e bar, e naught bar. So what are the expression of b naught, b1, b2 and b3? So b naught, so take b naught to make it by get, so b naught become e naught bar, b1 become e1 XOR e naught, b2 become e2 XNOR e1 ANDed e naught, and b3 become e3 e2 plus e0 e1 e3, that means e3 e2 e3 e2 plus e3 e1 e0. Now we can, so input are the e1 e2 e3 e4, and the output is b1 b2 b3 and b4. So we are taking input as this is your one line, this is your second line. Change the color to make it more catchy. So if we say that this become, we can say this become e naught, so this become e naught e1 e2 and e3, these are the input lines. So find, first you have to find b naught. So b naught is what? B naught is nothing but it is a e naught, that is the AND date, that means we taking the green color. So take the green color over here, and if we connect this with a NOT gate, then we can get, that is the B naught is nothing but the E naught bar. Now what is B1? So E1 XOR E naught. It is very easy. So B1 become E1 XOR E naught. This is E1. So take one red color. So E1 and E naught. E naught. We are taking E1 and E naught over here. And they are XORed. That means if we are make one XOR gate, then we can easily find the B1. If this is B1, it become E1 XOR E naught. Like that, if we want to find the B2, E2 XNOR E1 and E naught. So E1 and E naught are ANDed. So E1 and E naught are ANDed. So take E1 and E naught and E1 are ANDed. So make one AND gate. So this become E1 E naught. Now if the output of this AND gate is XNORed with the E2, that means take E2 over here and it is XNORed. So XOR and a NOT gate. So this is XOR gate and we want a NOR gate. So this become B2 is nothing but the, so this is your E2. So this is your E2 XNOR E1 E naught. Then what is the B3? So B3 is E3 and E2 are ANDed. So E3 and E2 are ANDed. It means one AND gate of white color, E3 and E2. E3 and E2 are ANDed. Then say this is ANDed, then this become E3 E2. Now and E1 E naught E3 are ANDed. So E3 E1 and E naught. E naught and E1. E1 means red. They are ANDed. So we have got that E3 E naught E1, E naught E1 and E3. So if they are connected with a OR gate, then we can get the B1, B naught B1 B2 and B3 is nothing but the E3 E2 plus E3 E1 E naught. So this is how we can find the B output, B0, B1, B2 and B3 from the Excess-3 code. So keep watching the video. Thank you very much.